Okay, so yesterday we talked about how to solve radical equations. Now we are going to talk about what you do when you actually have exponents other than a squared, because we did a whole unit where we had squares and square roots and things like that. But now there's other values that we could have for our exponents. So we're going to talk about, just to make sure we know how to handle things like these first four questions where we have things raised to the third power or the fourth power, and then questions like down here on the bottom where we have things raised to a fraction power, because we also need to know how to deal with that. So let's go ahead and start here with solving by taking the appropriate root, okay? So when we are solving an equation, this is not any different than what we've done before, okay? So we are going to look and be like, well, I need to get x by itself. Before I take a square root, a cube root, a fourth root, anything like that, I need to get x by itself. So to do that, first step, I'm just going to divide both sides by 5, and I have x to the third equals 8. Okay, well, normally we've solved equations that have been like x squared equals something. Well, this is x to the third, so to undo a third power, we are going to take the cube root. Okay, and we can use a calculator for this if you're not familiar with all the perfect cubes. However, I tried to make the numbers small enough that they should be ones you should be able to figure out in your head. So when we take the cube root of x to the third, that basically undoes the third, and we get x. And the cube root of 8 is 2, because 2 times 2 times 2 is 8. And in this case, we have an x to the third power. It's an odd power, which means if you have an odd power, you do not need to do plus or minus. Okay. However, when we move over here to number 2, we have a fourth power. So, just like we did on the last one here, if it's to the fourth power, and keeping in mind that x plus 3 is grouped with parentheses, so we cannot subtract the 3 first, we need to take that fourth root first. Okay, and whenever we have an even power, just like when it was squared, 2 is an even power, 4 is an even power, need the plus or minus out in front. Okay, so by taking the fourth root of x plus 3 to the fourth, that just gets rid of that fourth power. So we would have x plus 3 on this side. And the fourth root of 16, if you need to, you can use a calculator, is 2. But not just 2. Don't forget it is plus or minus 2. Okay, so then when we go ahead and subtract 3 from both sides, x is going to be negative 3 plus or minus 2. If we wanted to actually calculate that out, negative 3 plus 2 equals negative 1, and negative 3 minus 2 equals negative 5. So we would have 2 answers here. Okay, and since I'm not actually taking, it doesn't start out as a root or anything like that, like we did yesterday, we don't have to worry about any extraneous solutions. Okay, so let's just look at 2 more examples here. I have 2x to the fourth equals 32. Again, the first thing I want to do is to make sure that I get x by itself. So I'm going to divide both sides by 2. And I get x to the fourth equals 16. To undo x to the fourth, I am going to take the fourth root of both sides, which leaves me with just x over here. And don't forget, when we take an even root, okay, we have to think plus or minus. So that's going to be plus or minus 2, because the fourth root of 16 is 2. One more, kind of like that other one up here. If we have x minus 5 to the third, to undo the third, or excuse me, to the third power, I'm going to take the cube root of both sides. And I'm just left with x minus 5 over here. And since it's an odd root, I do not need plus or minus, so that's going to be the cube root of 125, which is just 5. And if I add 5 to both sides, I get that x equals 10. So this one, since it's not an even root, is not going to have 2 different solutions. Okay, so now we're going to look down here on the bottom at what happens if we have a fraction exponent. Okay, so we need to think how to undo a fraction, which we'll get to in just a second. Okay, so just like we did on the other one, we need to get x by itself. So I'm going to go ahead and add 10 to both sides. Okay, and then that leaves me with 3x to the 3/4 equals 24. One thing that's important to notice is that the 3 and the x are not in parentheses, which means the only thing being raised to the 3/4 power is the x. So that means that we can go ahead and we can divide both sides by 3, which gives us x to the 3/4 equals 8. Okay, now how do we get rid of 3/4? I want that exponent to be a power of 1. In order to do that, I need to take it to the reciprocal power. So if it's to the 3/4 power, I'm going to take it to the 4/3 power. Because 3/4, so like over here in a little thought bubble, right? 3/4 times 4/3 is 12 over 12, which is just 1, which is what we want. So that's why we multiplied it by the reciprocal. It's always going to be the flip. And if I take the left to the 4/3 power, I also need to take the right to the 4/3 power, which just leaves me with x over here. And if I have 8 to the 4/3, we're going to rewrite it. So here's kind of our last couple of steps. We're going to use the reciprocal to get rid of that fraction exponent, and then we are going to rewrite and solve it as a radical. So 8 to the 4/3, remember, is the cube root of 8 to the 4th. That's what we did last week. And the cube root of 8 is 2 to the 4th power still. And 2 to the 4th power is 16. Okay, so again, to get rid of that fraction exponent, we took it times the reciprocal, rewrote it as a radical, and then just simplified that radical. Okay, and just like yesterday when we did these, we want to make sure that we always check to make sure that solution is actually going to work. So we want to make sure we go back and put it into our original equation to make sure we're not having any funky answers or anything like that. So if we did that, we'd say 3 times 16 to the 3/4 minus 10 equals 14. If we add 10 to both sides, we get 3 times 16 to the 3/4 equals 24. If we divide both sides by 3, 16 to the 3/4 equals 8. And if we take the 4th root of 16, which is 2, to the 3rd power, we would get 8. So it's fine. We checked it and everything is just fine. Now, when we move over to question number 6, okay, we have x plus 12 to the 1/2 power. Okay, that x plus 12 right now is grouped together with the parentheses, so we can't just subtract 12 from both sides. But we can get rid of that 1/2 power by squaring both sides, because the reciprocal of 1/2 is 2 over 1, or just 2, which leaves us on this side with x plus 12 equals, and if we square the x, we get x squared. Then if we go ahead and subtract x and subtract 12 from both sides to get 0, because we have a quadratic, it's a squared function, which means we need to get it set equal to 0. We get x squared minus x minus 12. Okay, so now we need to factor it. So we're thinking what times what equals negative 12, and what plus what equals negative 1. Okay, well 4 times 3, and 4 and 3 here. If we get a negative 4 times positive 3, negative 4 plus 3. So our two factors are x minus 3, or excuse me, not x minus 3, x plus 3, and x minus 4 equals 0, which means our two solutions are going to be x equals negative 3 and x equals 4. However, we need to go ahead, when we have a rational exponent like this, we want to make sure we check that our solutions actually work. So if we go back up to our original equation, and if we put in -3 first. So I'm going to erase this here. If I put in -3 first, I get -3 plus 12 to the 1/2 equals -3. Well, -3 plus 12 is 9 to the 1/2 equals -3. 9 to the 1/2 is the same as the square root of 9. And if you remember yesterday when we talked about this, you can't have a negative when you take the square root. Remember, when you have that square root, you're assuming the positive value, which means -3 is actually extraneous. We can also check with 4. So if we did 4 plus 12 to the 1/2 equals 4. 4 plus 1/2. 4 plus 12 is 16 to the 1/2. The square root of 16 is 4. So those are both positive, which is good. So your only actual solution is going to be x equals +4. Okay, so let's go ahead and move over to the next one here. I have 6x to the 4/3 plus 8 equals 494. You might need to break out a calculator here. If I subtract 8 from both sides, I'm going to get 6x to the 4/3 equals 486. And if I divide that by 6, I get x to the 4/3 equals 81. Okay, so now I need to undo my 4/3, so I'm going to take it to the 3/4 power. Okay, that gets rid of my rational exponent there, and I'm left with x over here, and I have 81 to the 3/4 power. Okay, that is the 4th power of 81 to the 3rd. 4th root of 81 is 3, and 3 to the 3rd is 27. So let's just go ahead and do a quick check to make sure that actually makes sense. So if I have 6 times, what did I say? 27 to the 4/3 plus 8 equals 494. Again, if I subtract 8 and divide by 6, because I'm going to follow these same steps that I did here, I'm going to have 27 to the 4/3 equals 81. Okay, so is the cube root of 27 to the 4th power equal 81? Any negative issues in there? Nope, because the cube root of 27 is 3, and 3 to the 4th is in fact 81. Okay. Okay, as we move on, I kind of realized that I put the wrong number in here. It should be 2x minus 1, which is what your notes should actually say. Okay, so I'm going to fix it so it matches what you guys have, but I had already started here, so I did not go back and redo everything. But we need to make sure that we are getting rid of that 1/2. Again, 2x minus 1 is grouped together with parentheses. It's being raised to the 1/2 power. So to undo that 1/2 power, we are going to square both sides, just like we did on the question right above it. And when we square it, that gets rid of that rational exponent, and we are left with 2x minus 1 equals x squared. Okay, since it's quadratic, we need to make sure that we get it set equal to 0. So I'm going to subtract 2x and add 1, and I will end up at 0 equals x squared minus 2x plus 1. When I go to factor that, I'm thinking, all right, what times what gets me +1, and what plus what gets me -2. Well, in order to get a positive, the signs have to be the same. So I'm going to have a -1 and a -1, a -1 and a -1, which means my two factors are going to be x minus 1 and x minus 1, which means really the only solution we have is x equals +1. We just need to check to make sure that that actually makes the problem work. So we're going to go back up here and check it. And I'm going to say 2, I'm going to take out x and put 1 in its place, times 1 minus 1 to the 1/2 equals 1. I just took the x out and put 1 in its place. 2 times 1 is 1, 2 minus 1 is 1. 1 to the 1/2 is just the square root of 1. There's no negatives that we have to worry about in there. So this one actually, even though we had a quadratic, just has one answer, which is x equals 1. So what we want to do, I just want to make sure, I didn't write this up here, I didn't talk about it at the very beginning, but when we have a fraction exponent, we think about the reciprocal, solve it as a radical, and then we also need to make sure we check for extraneous solutions. Okay, so you have a class kick to work on when you are finished with this, so good luck, and I will see you guys soon.